CADWOLF is a web-based math and engineering platform. At the heart of CADWOLF are documents. Documents are simply web pages that have been formatted to have the appearance of a Word document. Users add blocks to the document by clicking on the GUI to the left, and then edit those blocks to have the desired content. Blocks can be text, equations, plots, and a number of other things. This equation uses some of our built-in functions, and when we click Enter, it is solved and then displayed in the proper mathematical format. Sliders and other HTML components can be added and used as equations, and when the item is changed, subsequent items update automatically. This means that documents can replace Word and PDF, as well as Excel in a programming language like MATLAB or Python. However, unlike programming languages, equations in CADWOLF track and adjust units, and our built-in functions provide for a great deal of complexity, such as the use of our ordinary differential equation solver to solve for the position and velocity of a bungee jumper in freefall. CADWOLF doesn't merely replace items like Python or MATLAB. CADWOLF variables can be sent directly to the onShape CAD system and used directly in models. In this document, we have designed a very simple system of a rod and two fittings holding a weight. As you can see, the mathematics in the document set the strut diameter, the bolt diameter, and the fitting thickness based upon the weight. When that weight is changed, the document updates to change the sizes and the fitting of the fittings, bolts, and the strut. Here is that system shown in onShape. Now, let's change the dimensions of the length, width, and height of the weight from 9 inches to 16 inches. We see that the remainder of the document updates, and then we save the file and those variables are sent to onShape. Going back to onShape, we see that the system has indeed received the variables and it has updated accordingly. While this single document was sufficient for the simple rod weight example, the part tree module helps us design large and complicated systems. In onShape, we have a simple truss consisting of 3 identical rod and fitting components and 2 rings on either side. The system is designed to hold a given weight. The part tree module lets the user create a part numbering system and then designate a document for the design of each component. Those documents can then be linked to an onShape part or assembly, as is done here, with the icon for that part or assembly shown. CADWOLF reads the properties of those CAD files, such as the weight, density, and material from onShape, and lets the user see them here. Now let's go to the document holding the design weight and the factor of safety for the strut. We change this weight from 10,000 to 30,000 pounds, and the factor of safety from 1 to 3, and then save the file. Going back to the part tree, we see that 3 documents are now outdated. One by one, we update those documents, and new properties are sent to onShape. When all the updates are complete, we read the mass properties back into the part tree, and you can see that the mass of the struts, fittings, and bolts have changed, and the resulting change in the mass of the total system is roughly 8 pounds. We just changed the 2 major controlling factors for this truss, and then updated their design and CAD model in just a few seconds, and instantly saw the results of those changes to the mass of the total system. CADWOLF not only takes the length of time required to do such a change from days to seconds, but it also guarantees that the documentation, analysis, and CAD are all in sync. The more complicated the system, the larger the benefit to using CADWOLF. Both CADWOLF and onShape are completely browser-based with nothing to download or install, and both have free licensed models.